We're not talking about this fuzzy thing. We will be talking about chemistry. Though the concept shares the name, moles are instead a weird type of unit. They're technically unitless, but operate like a unit when doing calculations. To illustrate this, let's talk about an unexpectedly similar concept: dozens. I could, if I so choose, refer to 60 eggs as 5 dozen eggs. The word dozen acts like a unit, and I could convert between eggs and dozen eggs using the conversion factor, which is 12. Moles are the exact same thing, albeit with a much larger conversion factor. The exact number is 6.022 times 10 to the 23rd, or about 600 sextillion, which is simply too large to come up with a human scale example. You would need over 16 billion people in order to have a mole of just human cells. The number of seconds the universe has been around is about 1.4 millionths of a mole. We cannot get an intuitive understanding of the size of this conversion factor. However, such a large conversion factor is necessary when talking about atomic scale counts. A coffee mug can hold about 19 moles of water molecules. Being able to refer to the quantity of molecules rather than the mass or the volume can be useful for measuring chemical reactions. This can be demonstrated in the reaction between hydrogen gas and oxygen gas. By moles, the ratio is 2 to 1, as H2O has 2 hydrogen atoms for every oxygen atom. However, the ratio of masses would actually be 1 to 8, because oxygen is significantly heavier. By measuring the gases in moles, it's more immediately apparent how much of each gas is necessary. Molarity is a unit based on moles that operates like a density. Typically, we think of density as mass in a given volume. Even though a pound of feathers and a pound of bricks are the same weight, the feathers take up a lot more volume, as they have a lower density. Molarity serves as the mole version of density, describing how many molecules of a material are in something per unit volume. Imagine a really good detector that can tell you if a vial of water contains more than 1 billion molecules of various poisons. Since different poisons all weigh different amounts, the concentration by mass would be different for each poison type. The molarity, on the other hand, would be the same for all of the poisons, as it only depends on the number of molecules and the total volume, which are both fixed. Moles and molarity serve as a bridge connecting the molecular underpinnings of our world with the scale at which we live. It allows us to refer to the exact number of molecules without having to break out the ridiculously big numbers to do it. I give my thanks to Amedeo Avogadro, whose work served as the basis for this concept's development, and is the reason that the conversion factor is named Avogadro's constant.